like you have Spark SQL, which is to process the structured data sets in a paradigm like SQL and so on, right? So there is another higher level API supported in Spark, which is also very frequently used these days, right? Which is called as Spark Streaming, right? So like Spark SQL, so Spark Streaming is an extension of the Spark Core API, which allows for processing of live streams, data streams, right? So basically streaming data. Okay. Right. So when you have, say, data from some input stream, okay, some streaming sources, okay, so the Spark Streaming API allows you to create this into discrete, streams. So which is nothing but what you call as a micro batch. The D stream that has been created from this streaming source will have micro batches for every whatever the time unit that you specify, that you configure, for this D stream, right? So the D stream would consist of multiple, micro batches of data, and each of those micro batch of data is in turn represented as RDDs. So each micro batch of data is in turn represented underneath as RDDs. So we don't have to worry about how to translate this into RDDs and then how to individually process them, right? So we can use this D stream, so collect data from any streaming source, and then we create D stream, and the D stream would internally be represented as RDDs. So we directly simply use the functions that are supported by for this D streams to manipulate this data. Now let's try to first import the some specific imports that is required for stream processing. So I'll say import, I hope this is working. So import org.apache.spark.sparkconf. Okay, and let's import Spark Streaming. So I'll say import org.apache.spark.streaming. Now seconds, comma, streaming context. Okay, and let's also import one more library called storage level. So I'll say import org.apache.spark.storage level. And let's import everything under storage level. So I'll say import storage level dot underscore. Okay, and we need some more imports for implicit conversion. So I'll say import org.apache.spark.underscore and import org.apache.spark.streaming.underscore and also the streaming context. So I'll say streaming context dot context. Okay. Now, so we have we have included all the required, libraries. So next, see, the first thing that we need to create is a streaming context, right? So in case of Spark context, it's already available in the shell. Now we just need to create a streaming context, build a wrapper around it. Okay, so I'll do it this way. So I'll say val Spark streaming context SSC is, I'll create a new object of type streaming context. So I've done all the includes, so imports, so it should be working. So I'll say create a new streaming context. Now here, for creating this streaming context, we need to get the Spark context, and we also need to set the batch interval, right? So now you know what is a batch interval. So the streaming use for this streaming context, you have to specify what is the batch interval, right? So Spark context is available here as SC, and next I need to specify the batch interval. So I'm going to set a batch interval of 2 seconds, right? So for 2 seconds, I'll use the seconds which is now included here in the API. So I'll use this time interval of seconds, and I'll specify that as 2 seconds, right? So now I've created a Spark context with a batch interval of 2 seconds. So if you observe now, SSC is basically an object of type streaming context. Now we have created a Spark streaming context. Okay, so let's try to use this streaming context to create some D streams, right? So basically collect some, do some real-time processing. Okay, so here in this example, I will try to show you how we can collect the data from some port, okay, as and when the data has been generated at that port, and access them through this application. Okay, so here I will use, so when we look at the SSC dot, and if I say tab, you can see all the functions that are supported by SSC, right? So you can see here these are some of the function that are supported by SSC. So you can see that there is a socket stream, socket text stream, raw socket stream, network stream. So these are all some of the functions that are supported, using which you can create D streams. Okay, so here in this example, I'm going to show you, I'm going to use this socket text stream method. Okay, and we will create a D stream which is going to basically listen to a port, okay, and whenever there is some data being generated at that port, okay, on some machine, it is going to collect that text stream. So basically it's going to look at whatever the using the sockets, right, it's going to collect whatever the data that has been generated at that particular port. Okay, so and it processes them as a text, right? So it can be some textual data, right? So I will say val lines. Okay, so I'm going to create some D stream called as lines by using this Spark streaming context and using the socket text stream method, right? And I will specify some port, on this machine, right? So I'm going to say the machine is the same machine, on the same machine, local host. Okay, listen to this port number. So I'll give some port number here, say 8585 is my port number. Okay, and I will specify this is memory only. So caching will be done with memory only kind of caching, right? So I'll specify these three options, and I will say create a D stream. Okay, so you can see here now what it's done. So it has created a discrete stream. Okay, so lines, if you observe this lines, so lines is basically a discrete stream, okay, which is the receiver input D stream of type string. Okay, so since I specified this as a text stream, okay, whatever the data that is being arriving at this port would be captured into this D streams. Okay, and this is basically a D stream of strings here, right? So basically we have created a discretized stream of strings. Okay, now the next step is I want to do some processing here. Okay, so I want to do some processing. So what I'll do is whatever the data that is arriving at this port, okay, I'm just trying to do some word count on that. Okay, so something that we are now familiar with, right? So how do you do the word count? You know how to do the word count using RDDs, right? So now I'm going to do the same thing here, okay, and basically processing this D stream just like I would process a RDD, right? So how would you do the word count? So we first said that first you create a flat map and create a basically divide the lines into words, okay, and then add 1 to it and create the key value pairs, and then basically use the reduce by key, right? So to do the count of words. Okay, so I'm going to follow the same step now here on the continuous stream of data, right? So I'll say words flat map. Okay, now I'll say that is equal to, I'll use the lines. So lines is a D stream here. So I'll say lines dot, I'll say flat map. Okay, so what am I doing in the flat map? So I'm basically applying this function on every element, that is on every line of this D stream. So I'll use the split, okay, and split based on spaces. So this is going to break the line into individual words. Okay. So you can see here now the word flat map is basically another D stream of strings here, right? So what is happening underneath the D stream? Okay, so every element is basically treated as RDDs. So the micro batches are treated as RDDs only. So you can see that you are processing it just like you're processing RDDs, right? Now the next step is I would create that word comma 1. So I'll say I'll map this. So words map is equal to words flat map dot map of W. I'll take every word and I'll say return W comma 1, right? So this, again, you're familiar with this. This was the step. So you can see here again, now we have created a D stream of string comma 1. So we are just processing it just like RDDs, because underneath the D stream it is just RDDs only, right? And next step was I said we can use that reduce by key to basically do the word count. So I'll say val word count is equal to words map dot, I said reduce by key, and basically take A comma B to consecutive words, and then basically aggregate them based on A plus B based on the keys. So A plus B, okay. So now you can see that it created a D stream of string comma int. Okay. Now Next step is I want to see the results. So I'll just say word count dot print. Okay, so I'll just say print. So nothing is happening here, right? So because nothing, I mean, you have not yet started collecting the data. There is no data, so there is, print is simply returning print. Okay. Now the next step is I will initiate this, right? So remember, nothing happens until the the streaming context is started. Okay, so you have created a streaming context and you have defined the batch interval, you have defined how you are going to process this data and all that. So this is a real-time processing. But nothing will happen until you start this streaming context to begin capturing of the data, right? So next step is to use the streaming context and start it so that you can begin the stream processing. So I'll say SSC is my streaming context and I'll say start. Okay. So observe what happens. So I'll open another window, okay, here, and I will try to start a netcat server here so that I can write something into that window. Okay, so I'll say NC netcat server. Okay, so I'll say start this netcat server at this port number which we are actually listening to from our streaming application. Okay, so now it is started. Now on this I'm going to type some lines here. Okay, so for example, to be or not to be. I am adding some more lines. So as and when I added the lines here, it is giving me the count of these words by processing these lines. So this is how we create a real-time processing. So basically, you create a streaming context, and using the streaming context, you create a discrete stream. So what it's doing is here it is listening to this port, and it is collecting every line that is being typed in, and every for every 2 seconds worth of data, it is creating a discrete stream, and it is doing that processing, whatever the logic that we are implementing for manipulating this data. And when you start this streaming context, it begins this processes in real time. So you can use this to do any sorts of real-time processing. So if you observe here, see the original D stream, okay, now every second, say supposing if you're talking of this the batch interval as 1 second, so every second, so this time is 1, this is nothing but the batch interval. So you are basically creating a micro batch. So the D stream consists of a series of micro batches or a continuous data which is sliced by time, right, based on this batch intervals. So you have data which is based on the D stream consists of micro batches. So this micro batch is nothing but an RDD. It is created as an RDD. Now when you are trying to do the reduce by key, now which one will you take? So here this is where you create a window length. So in this case my window length is maybe like say 3, so this may be 3 seconds. So you are considering the the data from 3 seconds as your window. So when you do the reduce by key, so it is going to take the elements in this first micro batch, second micro batch, and the third micro batch. So it does the reduce by key on this and generates the result, right? So that is the 30 seconds. So here maybe you can take this time as 10 seconds each, so that would be the 30 seconds. Now the second part is the sliding interval. So which means, so first I'm going to do the reduce by count on the first 30 seconds of the data. Now, when I say sliding interval is 10 seconds, so next you're saying, the next aggregation on the next reduce by count will be done after 10 seconds. So it's going to take time 2, time 3, and then time 4. Okay, so you are going to create a micro batch which encompasses these 3. So you are skipping this by 10 seconds. So after 10 seconds, you are going to do the reduce count again. So and then after 10 seconds, you'll do the reduce count again. So you are sliding this window length, or you are sliding this window by every 10 seconds.